Hello, everyone. Good morning, and thank you for making the time to be here. Uh, my name is Deepak. I'm a software engineering lead at PayPal Big Data and Data Platform Engineering Organization, and I manage a couple of products, Gmail and UDC, which are open source by PayPal. And I also have with me here Harsh Bhimani, who is the senior software engineer working with me on UDC. Right. So today we are going to talk about recommendation systems on UDC, how we built it using combination of Neo4J, Spark, and a few other stuff. So quickly, the agenda that we will be going through in the next 30 minutes. We'll have a very quick look at what unified data catalog is. This is just to set the context for us to navigate through the remaining part of the session. And we'll also look at why we built a recommendation system for a data catalog and the overview of the things that we considered for recommendations, followed by the deep dive and architecture, which Harsh will be covering. And also, we'll talk about how we plan to expand this concept beyond just being the recommendation system for UDC. And finally, we'll pause for questions if there are any. So, what is Unified Data Catalog or UDC? UDC is basically the enterprise data catalog. It's a homegrown product in PayPal. We developed it from scratch, and it's you can think of UDC as a Google search, but for the metadata of all the data assets we have in PayPal. When I say data assets, you can think of various stores such as Hive, Teradata, MySQL, Oracle, cloud stores, Kafka, Elasticsearch, and various other things that an enterprise would have. So UDC is meant to serve as this search portal where one can come to the portal and then search for some data assets and then self-service. So when we say a data set, it's nothing but a single object that might reside in some store, like a table in a database or a topic in Kafka or an index or a document in a document-based database. So we expect or we envision the user to come to UDC and then look for data sets, determine more information like owners, usage, statistics, access controls, and then finally figure out if that is what a user requires to fulfill their job duties. When I say user, it could be different personas, could be data engineer trying to create pipelines, looking for data sets that best fits their need, or an analyst trying to create a report or dashboard, which might require combining data sets from different stores, looking for information like business metadata and so on, or even an ML engineer who is trying to build and train models, who requires data from different stores. Most of us here I'm sure, will acknowledge the fact that building a model these days, the toughest part is sourcing the right data and then training the models with the right data sources. Creating the pipelines for those data sources is a big job. Apart from that, we also have other personas of late who are wearing the business hat, but trying to fulfill GDPR privacy compliance. So all of these folks have this big problem of finding the right data sets that require to fulfill their job needs. That's what UEC strives to solve. Coming back to a very high level view, like 10,000 foot, UDC is basically nothing but a meta store, which has all these different stores that we scan within PayPal. You can think of the analogy of a Google search. Google scrolling all these different websites and then indexing them, and then there is the notion of page ranking algorithm, which basically applies and then when you go to Google and then you search for something, you get the sorted results. Now you can apply the same analogy for the data assets. In an enterprise, we have this notion of discovery services, which goes and crawls all these different stores that we may have in an enterprise. UDC indexes the metadata and then applies sorting, ranking, and all of those algorithms, and then the user comes to the portal and then self-services his or her needs. So, why recommendations for a data catalog? If that's a big question, we need to go and look back at the growth story for our data catalog, UDC. It's been almost 20 months. We started UDC as a side product or a supporting config system back in 2018 for our own big data framework, which we call as GIML, which was open source by PayPal. And we saw the potential for that config system to become the actual data catalog for analytics itself. So we spun it off as a separate product, put the UI on top of it, and then made it the data catalog for analytics. Very quickly, we realized the power of such catalog, which is homegrown, which has access to all our data stores. Then we finally have this as our enterprise data catalog right now. On the other side, we have over 1,000 internal users who are currently using UDC from various locations across the globe, and a lot of different delivery organizations who wear the functionalities of risk scientists or financial reporting analysts or data engineers and so on. And it's just the beginning for the data catalog. We have 250 plus data stores, but this is probably 1 to 2% of the entire data asset we have. So within that 250 plus data stores, we have more than 1.7 million data sets. Now you can imagine the scale when we go ramp up and go to 50% or 100% or close to 100%. There's going to be this humongous amount of data assets in one catalog. How is the user going to then come and self-service their needs? And if you take this analogy or scale and then apply to a well-known platforms such as Amazon or Netflix, it's no-brainer. All of these platforms created this recommendation system to make sure the results are targeted to users based on their profile, their activities, and really the users are able to use those search results to quickly do what they want and move on. So how can recommendation help in UDC? So as I mentioned earlier, we have various personas: analysts, scientists, developers, administrators, and more recently we have a lot of folks from the business group trying to serve or answer questions around GDPR, compliance, security, privacy, which is becoming increasingly more critical for running the business. And to see the other side, the scale, we encounter this classic what we call as the long tail effect, where 95% of the data sets that we have or the products that we may have in a catalog may not be as influential as the top 5%, which is really usable, influential, and effective for most of the people who are doing the job. So how do we make sure the results in UDC are very effective for users who come in wearing this different persona? How do we make sure we have those top 5 to 10% of the data assets which are really influential pop up in the top search results? These are the two problems that we are trying to solve by building the recommendation system. So with the user profile and their activities plus the dataset profiles, combining them together will give us this power to create and personalize recommendations, which will make the user experience better for the users and also make their serving needs very fast on the UDC portal. So we ended up building the recommendation system. We'll take you through the journey and the details, but this is what it looks like today. If you follow the arrow marks on the top right corner, I have myself logging into UDC, and this is the, like I mentioned, the search. But what we have at the bottom is recommended for you and topics. Um, Recommended for you is more personalized based on various signals that we take from different things into consideration. Top picks is more like a page rank result, which gives you the top uh, searched L datasets or top view datasets or top access datasets. This is running in the beta mode as of today. So, having started the recommendations and trying to build the recommendation, we stumbled upon this classic challenge which any other system of recommendation comes across, which is called as the cold start problem. So when you build a recommendation system, you could take various approaches like collaborative filtering, content-based filtering, which will help you solve the problem of recommending something to users from different perspectives. But the big problem the system faces is when the user is new, as in the user lands on the website the first time ever. How do you recommend something to the user? And when you recommend, how do you make sure it's not garbage or it's really usable for the user? These are the two problems which we wanted to solve because, as I mentioned before, it's just the beginning of UDC, and we expect to have a ramp up on user base, and all of them are going to be mostly new users. Not only that, when somebody new to PayPal joins the company and then they are looking at UDC, how do we make sure they get something which is very usable for them? This is where we had to make the choice of how do we do the recommendation. So we ended up concluding that we need to build a graph of things. When I say things, all the connected components in the data ecospace, which will help us connect users with various other activities and other aspects in the system, thus helping us determine what is the persona of the user and also make sure we are able to come up with a recommendation that is really useful for the user. So we came up with this conceptual model of what we wanted to build. If you follow me on the top right of this graph, we have this very high level view of the company, which is nothing but PayPal Inc. And then we wanted to start from there and have a complete depth of graph where we can go and traverse through various adjacencies or what we call as the companies that we acquired in the past, maybe Braintree, Venmo, or Paydiant, or Hyperwallet, and so on. And if you take PayPal itself has site and PayPal analytics. If I go deeper into analytics, it has various stores. This is just an example for the concept. There is a Hive, bunch of Hive clusters, a bunch of Kafka clusters, but within a Hive cluster, there are so many data sets in the order of thousands or hundreds of thousands. Similarly, there are a few hundred clusters we have in PayPal. Each of them have hundreds of data sets or topics. And if you look at the red dots that we have here, the nodes, these are nothing but the access controls, the roles that somebody needs to access the databases or the system or the tables or the topics. So this is like another subgraph of access controls, while this is the subgraph of the PayPal organization. This is the subgraph of all the data stores. On the left side, you have the subgraph of people. Um, I report to, let's say, Don, and Don has two reportees, and Harsh and Jim report to me, and we belong to these organizations, which is internal to PayPal, and then we reside in this location. So if you start putting together a graph of all these different things, and then start attaching to this graph by augmenting the dataset activities, it's really a gold mine, and you can do a lot of things with it. So this is what we realized will help us not only build a recommendation system but also expand it to many more things in the future. So with this concept, we explored a lot of options. We explored various graph databases, and then we finally ended up choosing Neo4J for persisting and creating the graph, and for processing the data from various sources, and also to draw recommendations. Even if you want to do it outside of Neo4j, we wanted some good processing engine and operating at scale. So we decided to use Spark and graphics. We are heavy in Spark in PayPal, so a lot of expertise and a lot of support for Spark within PayPal, so that fits well. And Gimel is something which we open source, which helps us access various stores at scale with ease. It makes the integration easier. While Neo4j really helps us meet all our storage requirements like asset compatibility, good visualization, integration with Spark and various other stack, even good support for Python programming languages such as Java and so on, and especially the epochs, which are very useful for us to draw some algorithms within the database without having to import all the data or export all the data out of the database. So with that being said, we ended up building the graph um as a POC or as the initial concept. So what we have here is a recorded demo of what we have built. You can see all of these different subgraphs of organizations which are basically disconnected, as in the orgs or silo, you can connect the organization. But once you start clicking into one organization and then expanding that, you will see more connections between the organizations in terms of the location, or in terms of the assets the organization own, or in terms of people. Two different personalities from two different people wearing the same persona from different organizations have the same access controls or own the same kind of data sets. So a lot of connections can be drawn, uh, which is usually not very easy to perceive when you look at all of these from different aspects. As in, if you look at the org aspect, or if you look at the data asset aspect, or if you look at the access control aspect, or even something else like building a use case and creating pipelines, there is some commonality or touch point, which is what we ended up building by putting together all of these different connections and building a big graph of connected components. So, with that introduction, I would like to hand it over to Harsh, who is going to walk us through the internal architecture and the implementation of the graph. On to you, Harsh.
Yeah. So should I share the screen?
Yeah. Okay. You can,
No. All right. So thanks, Deepak, for giving an introduction of UDC and also explaining the need of having a recommendation system for UDC. So now that we know that why we need a recommendation system and why we went ahead with Neo4j, let's do a deep dive into the actual architecture of what we achieved. So when we talk about recommendations in the architecture, basically there are two components. One is building the graph of the connected components as Deepak showed, and second is actually getting the recommendations out of it. That is mining the recommendations out of it and then viewing it back on the screen on the UDC UI. So for building the graph, say for example there is a user that comes to UDC. We capture some information for that user. So first we capture the UDC the logs for that user. That is all the previous data sets that the user has viewed in UDC so far. We capture all those logs into Elasticsearch. So we get all those logs, we load it into Neo4j. We also have another PayPal analytics product called PayPal Notebooks, which is just an internal version of Jupyter Notebooks that is heavily used by analysts and data scientists within PayPal to query these data sets and then also basically mingle with the data. So, and also those logs are captured in Elasticsearch. So both these logs are extracted from Elasticsearch and loaded into Neo4j. Then we also get the user manager relationship. So as Deepak mentioned, we can connect all these multiple nodes by some common aspect. So for example, there are multiple users that report into a common manager. And similarly, there are many people who actually report into a common organization. So for that, we are capturing this user-manager relationship that comes from one of the internal PayPal products, and also we capture information like which location does the user work at, and then also which organization does the user belong to. And then we take all this information and then we clean it, of course, and then we load it into a graph. Now this is a chaotic graph. It's a big one. It's a graph of all the entire connected components, and what we have to do is we have to mine recommendations out of it. So the next step, we load this in Neo4J. So the next step begins with using Spark and graphics libraries, and we use these libraries and Spark to generate recommendations out of this graph. So when I talk about recommendations, as Deepak had showed on the UI, we have two different types of recommendations. One is recommendations for that user specifically, and there is something called as topics, which is the globally most popular data set within PayPal. So these two categories are mainly generated using the graphics libraries and Spark on Neo4j. In the first one, that is recommendation for the user specifically, we captured basically two signals. One is the data sets that were viewed by the user most number of times, that is user views, the top views by that user, and also something called as group affinity. So group affinity is something where we use a user's relation, like where who the user reports to or what organization he belongs to recommend some data sets to him. This essentially solves our cold start problem. So as you can see here, we use Apache Airflow for all the scheduling of this recommendation engine, and we come up with three different types of recommendations where we capture three signals initially. So we have topics, that is all the topics. That topics is basically the globally popular data sets within PayPal. They are which are viewed by most number of the people, because as we can see, the scale at which UDC is operating, we have 100 plus delivery teams and 30 plus locations that are accessing UDC day in and day out. So we need to capture the most popular data sets and show it to the user. That is like the most basic recommendation that we can show. We also show user reviews, which is again total calculation of total summation of all the total number of views for the data set for that user, and also the group affinity. We load all this data into UDC Metastore, which is MySQL, and the UDC UI makes a call to the UDC Metastore to view it on the UDC UI. And so this is how basically, if I just in a nutshell, this is how the architecture looks like. We have a chaotic graph of connected components on the left, and then we have an abstraction layer. Oh, sorry, just a second. Yeah, sorry. So we have a full graph of connected components on the left. We have an abstraction layer, and then when these recommendations are surfaced into UDC, this is how they look like. And as I said, we have two different categories: recommended for you, which captures two signals, the top user views and the group affinity, and we have top picks, which are the globally most popular data sets. Moving on. So now let's dig deep into this three different types of data source. So one is the group affinity. In group affinity, basically, what we do is we get the users. If there is a user who comes to UDC, we get his manager. We get all the users within that manager, and then we get all the users who report into that manager and get their views and recommend it to the user. So as you can see here, we have the query here, and then we run it. So on the left, if you follow my cursor, this is the user Harsh who is coming to UDC. We first get the manager, because now we have a connected graph of everything in Neo4j. We get Deepak, who is Harsh's manager, which is this node, and then we get two other users who report into Deepak, and we get all the views of those users in UDC. Like we get all the datasets that they're accessing in UDC, and from there we make a common list of datasets, and then we sum up the total number of views for those datasets, and whichever has the highest view is recommended to this user. So this basically solves the cold start problem for us, because if the user Harsh is coming to UDC for the first time, we are banking on the fact that some members under the same manager must have used UDC and must have used UDC in the past, and they have viewed some data sets. So we bank on that fact and we recommend those data sets. Of course, this is just an idea, and we can even extend this concept to the user organization level, where we recommend data sets at the entire organization level to one particular user. So this is how the group affinity works. And then again, when we surface this results back to UDC, we have something like this. For any user Harsh, we have the dataset IDs and the total number of views. So this is how we recommend the group affinity results. The next one is the user views, which is a pretty simple recommendation where we just get all the views for a particular, all the dataset views for a particular user that comes to UDC, and then we just get the maximum. We just add the total number of views repeated for that user, and we show it to that user as a recommendation, and which falls under the user views category. So this is that. And moving on, we have the global topics, which is again this is where we get the most popular datasets within PayPal. So of course, everything that we do it in PayPal notebooks as of now. So here we are loading the graphics libraries. We are getting the relationship. We are loading this particular relationship of username, view dataset, and the dataset into Neo4J. We are applying a page rank algorithm directly, and this becomes easy using Neo4J because we can just implement the entire page rank algorithm on all the vertices of this particular relation that we have loaded in Neo4J, and which generates something like this, which says which is the most popular dataset today that has been accessed in UDC. And we just translate this back into UDC and show it on the UI. So these are essentially the three different types of recommendations that we capture using Neo4j and Spark and graphics libraries. And going back and giving a recap on how we show it in the UI, as you can see, there is this recommended for you, and then there is this top picks. So top picks is again the globally most popular ones, and the recommended for you captures two signals, which is the top user views and the group affinity. So this is essentially the whole recommendations architecture that we have. We definitely have a future plan for these recommendations, which I would like Deepak to expand
on. Thank you, Harsh. Just to reiterate on what Harsh mentioned about the personalization. Although the demo or the recorded demo that we have is only at the organization level for getting the connected components at group affinity, we actually expanded that to various other things like the user activities or user profile based on the roles that they have and so on, which is a little bit overwhelming to showcase in the demo. So the group affinity is a combination of various aspects, and giving the org is what we felt is something which is simplistic to show and explain. So the as a net result of what we ended up doing, we basically built a graph of all the connected components which belong to the data ecosystem. So when you now look at it from outside the box of UDC, it's like a gold mine, as I said, because we have all these different views which was not there before. So we feel the power of this graph can be extended beyond UDC, where UDC can just be a subset of the various use cases that we will really try to solve. So now we are trying to augment this graph by bringing in various other signals, like bringing the entire workday org structure or the complete identity controls and the links to the databases, and the owners, the queries, the users of databases, the lineage of how people query the data and what sources are used, and then the documents, as in we might be using Jira for issues, mentions, Wiki for documents, documentation design, or any other form of architecture. Then we talk about data sets in various Slack channels where we socialize about data and analytics. By tapping into all of these different places, we can actually make it much more powerful and usable for not just recommendations for UDC beyond that. So we can definitely see the power of this for solving GDPR or compliance or privacy needs, where we can figure out what are overutilized roles, underutilized roles, for example, rationalize the access controls, make sure there is no hotspots or highly influential nodes, which may or may not be legitimate based on the security needs of the company. So that is the plan going forward. make this graph robust, production grade, and then expand it to various other use cases. That summarizes the whole session. Again, thank you for listening to us with all the patience. I will open it up for questions.